In today's session, we will be seeing about the design of synchronous up counter. That also we will be seeing about 3-bit up counter. Here, when I say it as a 3-bit, it relies on the formula 2 power n, 2 power 3. So it will count, it has to count from the bits from 0 to 7. So I want the numbers to count from 0 to 7. For this, though you see various K-maps have been drawn, only if you know the excitation table, you can design a counter easily. So this counter I am going to design using JK flip-flop. So you should know the excitation table of JK flip-flop. What is excitation table? Given the present state and the next state, if you are going to find out what is the transition which causes this input, this is called as excitation table. Okay, so you should just remember for JK flip-flop, write the values from 0001, 1011, and here it is 0x, 1x, x1, x0. Only if this is known, the entire setup designing can be performed. Okay, so now this excitation table, it is going to be written in a broader way here, that's all. So just put the clock pulse because I am going to count 8 states from 0 to 7, right? So 8 clock pulses have been written. I have to count in the upwards manner in a sequential way. So the present state will be QC, QB, QA. I have written the numbers from 0 to 7. When I go for the next state, which is represented as QC of t plus 1, QB of t plus 1 and QA of t plus 1. So what is the present state? What is the next state for this 0, 0, 0? It is, the next state is 0, 0, 1. So this only it is going to be written. So for 1, the next state will be 2. So from 1 to 7 you will write. After that, this 0 will come here. Only this logic the student should know. You should write the values from 0 to 7 in case of present state, 1 to 7 and then 0 in the next state. Once this is done with, then you have to compute the value for your flip-flop. Okay, you have to compute the input data, what you have to give it for your flip-flop for designing it. So you have 3 flip-flops, so JC, KC, JB, KB, JA, KA are the inputs. Now what is excitation table? Knowing your present state and the next state, if you are going to compute your transition between the inputs, right? So now my present state is 0, QC. You can just see this arrow mark. It is 0 and QC, next state is 0. So for 0, 0 condition, what is the value? 0x. So just write it here, 0x. Okay, now if you want to consider this QB and QB plus 1, you can consider this value is also 0, 0. So it is 0x. Now you compare QA and QA of t plus 1. So it is 0, 1. For 0, 1, it is 1x. In this manner, the entire table has to be framed with. Once this step has been done, the next thing is you have 6 inputs. You are going to design a 3-bit counter. So I have just drawn the diagram for 3 flip-flops. Okay, just draw the outline and keep JA, KA, JB, KB, JC, KC. Sorry, this is JC, KC. And the outputs are respectively, output will be complement to each other. So it is QA, QA bar, QB, QB bar and QC, QC bar. Since it is called as a synchronous counter, I have just put the clock pulse to all. Even this logic one need not be written. Okay, so just draw 3 flip-flops, write the inputs and outputs, put the clock. Okay, now I have just drawn 6 K-maps for pertaining to all these 6 inputs. Okay, so now what is how will you write your K-map or your truth table pertaining to your inputs? What are the outputs? So 0, 1, 2, 3. In place of 3, I have put 1 plus 4, 5, 6, 7 are don't cares which has been mentioned here. Suppose if I take the case KC, 0, 1, 2, 3 are don't cares. So 0, 1, 2, 3 are don't cares. 4, 5, 6 are 0. So you can leave it and 1. In this manner, I have to plot all the K-maps. Okay. Now let us go for the grouping. Now here there is no need for me to go for the don't care grouping because don't care is nothing but if you want you use it, else you don't use it. A simple example is that if I want to go to 7th floor, I will go only for 7th floor. Okay, though there might be the lift operates for 14 floors. Okay, but if I want to go for 9th floor, in that case I will go for 4th floor, 7th floor as well as 9th floor. That is don't care. If you want, I will use, else the remaining floors in the lift, I will not use it. In this case, always we go for the don't care to group the larger amount of cells so that the circuit will become economical. Okay. Now here, I have to always check the grouping with the ones and not the grouping with the don't cares. Okay, so it is only a 2-cell grouping. The answer is, it lies here, QB into QA. So which has been written here. Now we will move for your KC. So here also it is going to be a 2-cell grouping. It is going to rely on the same thing. 0 and 1, it is not matching. QB and QA, it lies in this cell. So 1, 1, it is QB into QA. Okay, my JC and KC relies on the same value. Now we will move on to your JB. JB, in this case, you cannot go for a 6-cell grouping. Always go for a higher cell grouping. But here 6-cell grouping you cannot go. So only in the powers of 2 powers, I will go in for a 4-cell grouping. If I am going to group only this once, it will be just a 2-cell grouping. But always I need a higher cell grouping. So check the row wise, 0 and 1, it is not matching. In this, the first variable you see 0 and 1, it is not matching. Second variable 1 and 1, it is matching. So the answer is QA. Similarly, come for your KB. Okay, so this is JB. When you come for your, I think this is not KB. 1 minute, what is the value for KB? 0, 1, 2, 3. So 0, 1, 2, 3. This is your KB actually. So whenever you are going to consider this KB value, again I am going to have a 4-cell grouping. So my answer is QA. Now this is expression for my JA and KA. In JA and KA, if you are going to see, it is going to rely on the same values. So when I will always go for a higher cell grouping. So the value will be 1. Here also the value will be 1 because all the cells are grouped. So the answer is 1 here. Okay. Once you know this K-map grouping, you have to just draw the diagram and you can design it. So students, there is no need to worry. Only if you know the excitation table, you plot your flip-flop input function, draw the excitation table. Once this is done with, you are just plotting the K-maps and arrive at the expressions. Once you know for this input what is the expression you require, you draw it in the logic diagram. So JA and KA are 1. So just take one logic 1 and give it here. Now what is this JB and KB? It is nothing but your QA. So this JB and KB is nothing but QA. So from this I am just going to draw this line. That's all. From QA it is nothing but JB and KB. Okay. So QA corresponds to JB and KB. Now this JA and KA 1 done. This is done. Now what is the input for JC and KC? It is nothing but QB into QA, right? So here what you are going to do, QB and QA, it is multiplication function. So put a AND gate and connect it to your JC, KC. That's all, right? So the output is QB into QA. Take the output from QB and QA, put a AND gate, connect it. That's all. The design of the counter is done with. So this counter will count the numbers from 0 to 7. Suppose I want to change this counter as a down counter. Okay. If I want to change it as a down counter, means it should count reverse. So in that case, instead of taking the output from QA, QB and QC, I have to take it from QA bar and QB bar. Okay. So this will function as it will count in the reverse order. So with this, I conclude students. Thank you.